Day 1, Chapter 3, Learning Target 2. Let's evaluate some awesome things. This is Miss Ozier.
And Miss Lahar.
And here we go.
Domain.
X's.
There you go. I don't remember. Domain is all the possible X values that can happen.
Mm-hmm.
So if you think about it, the only things that come up that have errors is if you divide something by 0. Or if you have a negative underneath a radical.
Aww.
Just like you dropped your ice cream cone.
That's my sound effect.
Those are the bad things that happen, that can't happen.
In mathematics.
In mathematics.
There are many bad things that can't happen in life, but those are the mathematical things.
Range is all the Y's that can happen. There's no restrictions because you're dependent on what the X value computes
Right, so
to.
your range is pretty much everything.
Okay, ooh, this is good. So a lot of you have had question about like interval notation versus set builder notation versus, you know, and this is a beautiful diagram to do it.
This would be a good screenshot if you're confused on that. Let me stop moving the mouse. Okay, screenshot it. Okay.
Yep, screenshot. So remember, if we have an open circle, that's going to be the curved parenthesis. That one, interval notation is usually the most used.
So easy.
Yep. The square parentheses is a included value.
So it's or equal to, it's a filled in circle.
Yep.
And or equal to less than, you guys should know.
Yep,
and then
that's
same
set
thing here.
builder, that's inequality notation. So these are all the things. I do want to include that you should always go from smallest to largest. Some of you have been swatching positive infinity to negative infinity.
Right,
yep, left to right, small to large.
Okay.
Anyway, okay, that was just a...
So, domain, furthest left value to the furthest right value. Range, lowest y value to the highest y value. So if we were identifying the domain and range of a linear function, we would graph that linear function and we would see, from the left to the right, well, I go forever to the left, I go forever to the right, so it'd be negative infinity to positive infinity. I go forever down, I go forever up, so that would also be negative infinity to positive infinity.
So every single linear equation will always be negative infinity to positive infinity for both domain and range.
Right, everything exists. Quadratic, it's going to change because you got the hump. You either got the hump going down or the hump going up.
Most often you should graph it just to kind of look at it.
Yes.
Okay.
So domain left, I can go keep going to the left, I can keep going to the right, but up and down are what matters. So my domain is negative infinity to positive infinity. My range
I'm just
starts at 3.
Yeah.
And goes down.
So again, that would be negative infinity to the positive 3 value.
Because we go from the bottom to the top.
And domain will always be negative infinity to positive infinity for every quadratic. It's the range that has the issues.
The range, because it depends on what you put in. Hence why it's the dependent variable.
Okay, a polynomial is a term that has a couple terms in it. An odd one, so the leading coefficient is odd, is going to end up giving you a graph that has no restrictions whatsoever.
Nope. Everything.
You can go all the way to the left, all the way to the right. Any x value will work. Any y value will work. So domain and range are both negative infinity to positive infinity.
Now, an even degreed polynomial will work very similarly to a quadratic. You're going to have restrictions on your range because when you have an even degree, think about it, it's going to make things positive. So things are going to go up, up, up.
So the range on that one, I look, the lowest value, the lowest y value was -6, that value right there, and it goes all the way to positive infinity.
Okay, radicals. Again, you need to figure out what can be inputted and what can be outputted. So x, there are restrictions. You cannot have a negative under a radical. So that restriction is easily shown on the graph. It would be 3 and up. 3 is not included because 3 would make it.
You could have 3.
Oh yeah, you can have 3.
That's supposed to be a square.
That should be a bracket.
Because you can have 3. If you plugged in 3, you'd get 0 underneath, which
And
is
that's
still
cool.
fine.
Yep.
So that should be a square parenthesis. Now, my lines are a little off, but
Range, yep. Go ahead.
you go from the kind of the -5 at the end. You can see. Okay, so that would be from there
Up.
Yep.
And it's coming from, if you input 3, because that's where we said we can start inputting, that would be your output, is -5. Okay, exponential, domain and range. Again, look at the graph. Domain is everything. Everything works. And your range goes from the bottom, and in this case, to 0. It can change depending on what it is, but in this one, it's 0.
A lot of times putting it in your graphing calculator will help you out.
Oh, yeah. Graph.
Logarithmic, you shouldn't have to because we went over this in the log
know.
chapter.
Yep.
Domain, remember, you set that parenthesis greater than or equal to 0 and solve it. So this would be 1/2 to positive infinity.
And your range is negative infinity to positive infinity, always.
Same thing with the natural log. Again, you set that piece greater than 2x plus 11 greater than 0. Solve it, you get -11/2. And the same for that one.
Look at us go.
Oh, there it is.
Domain and range, domain and range. Okay, graph that bad boy. I can clearly see my domain has no restrictions because I can go left and right all over. My range is going to be affected because I have a start point on the y-axis.
So
Boom,
negative infinity,
boom.
and boom, there you go.
And that should be close brackets.
Close brackets because it can go from -2 to positive.
Hey, that's it. Have a great day. We'll see you in class.